Okay guys, so we're at our second video of this lesson, but it's going to be quick. You remember what we did here? We were doing composition of functions, did f of g of x, and then now g of f of x. Let's go ahead and see where the rest of this takes us. Two more examples, we'll be done. Here in example 4, we're going to be finding the domain of the composition of these two functions, f of g of x. And one might think it's just a matter of recognizing, and this is partly true. So part of it is you do want to not use that. You do want to recognize that we're taking the composition of f of g of x, and so I can rewrite it like this. So it looks a little bit more like function notation, and you know how I like to do it. I like to write the f function with all the blanks in there. So f of blank is equal to the square root of blank minus 4. You plug in the g of x and then you keep going, right? But it's not that simple, and I'm going to tell you why. The reason why is because we're looking for the domain. And when you're looking for the domain, you need to keep in mind those couple of things when you have these functions together. So remember square roots and dividing by 0, those are places where we need to be concerned. Not only do we need to be concerned about, we need to think about what this function is. This function is a function that is, all of its inputs is dependent on what g of x is. I'm going to say that again. This function is dependent on all of the values of g of x that can make this thing make sense. So it's like we have to get through two barriers first. First, we've got to get through the g of x barrier. Then we have to think about whatever restrictions would be on the f of x function. So before we even consider what this function looks like, because they really didn't ask us what the composite function is, they asked us to figure out what the domain is, let us think deeply about this. I'm going to take this and put it away for now. This to the side, and I want to think about what the restrictions are on both of these functions. Since everything that goes into f of x first relates to g of x, let's think about g of x. Are there any restrictions that you could see on g of x? Remember, anytime we have a fractional or a rational equation, we know we need to think about the denominator because we can't divide by 0. There's no radical here, so I'm not really concerned about that. But I definitely see that x cannot be 0. So that's thrown out of the pool for our domain. X can't be 0 clearly because it wouldn't work in g of x, therefore it wouldn't work in the rest of it. However, are there any restrictions that we have to consider for f of x? Well, funny you should ask, because this looks a lot like a problem that we did before. And here we know that we don't want to take the square root of a negative number. We can take the square root of 0, but we can't take the square root of a negative number. So in this case, when we think about what's happening here, we know that the inputs for f of x, which are going to be g of x, have to follow the domain restriction of f of x. I'm going to say that again. Whatever the domain restriction for f of x is, g of x the values for g of x must comply. So let's see what's going on there. F of x cannot be, we know that x minus 4 has to be greater than or equal to 0. You guys are with me on that. I could take the square root of 0 and I could take the square root of anything greater than that, but less than that, negative numbers won't provide me a real answer. And therefore, when I solve for x, x has to be greater than or equal to 4. But this x right here is not the same x that we're talking about here. We're talking about two different functions, so let's make it plain. This x, I'm going to color orange. Anything that I put here in for x, in terms of f of x, must comply with this restriction. What am I putting in there? I'm putting g of x in there. So g of x has to comply with this restriction. So what that really looks like in terms of an expression is that g of x has to be greater than or equal to 4. What is g of x? It's 1 over x squared. Now here comes some algebra. We need to remember our old algebra from back in the day. So if g of x is equal to 1 over x squared greater than or equal to 4, what we need to do is solve for x. In order to solve for x, let's get g of x out of the denominator, okay? There's a number of ways we can consider that, but one way to do it would be to multiply both sides by x squared. I'm comfortable doing this because I know that x squared is positive, because when I square any integer or number, real number, it's going to be positive, so I know the sign's not changing. Oh, the math. And I end up with 1 is greater than or equal to 4x squared. Still haven't solved for x, but I got it out of the denominator, which is kind of a pesky place to have x in order to solve. Let's keep going. I need to get x by herself, so I'm going to divide both sides by 4. And now I'm getting closer. So 1/4 has to be greater than or equal to x squared. To solve for x, I need to take the square root of x. But when I take the square root of x, I must do something very special. When I take the square root of x squared, rather, I must do something special. I can't just say that I know for a fact that this answer started off, x value started off as positive. It could have been negative. So I can't just say that the square root of x is going to give me 1/2. But I can say that the absolute value of x, which is the square root of x, has to be less than or equal to 1/2. Are you guys with me? I took the square root of both sides, had to take the square root of both sides, but when I do that over here, I have to keep in mind that x could have been negative. So what I'm talking about and what I'm comparing this to is the positive version of the answer. So that's why I put absolute value signs around there. And do you guys remember what this is equal to, how we handle these types of problems? I'm going to write it a little bit differently. So this is the absolute value of x is less than or equal to 1/2. And we have a whole system of solving these types of problems. We can go back to it later, but we know that the equivalent way of writing this is to say that x has to therefore be between -1/2 and 1/2. And that is indeed the case. So we know that this would be, this x is the x that we're talking about in terms of the x's that we're putting into the function. Oh, I know this is crazy. And therefore, this is going to give me the domain. However, let's not forget about the restriction we already had, that x can't equal 0. So these things coming together, remember this x wasn't really x, it was g of x. And so I know you guys are like, what? I promise this will make sense. Watch it twice if you have to, but let me bring it home. The domain of that composite function of f of g of x, even though we didn't find out exactly what that function looks like, and I get it, I know you wanted to, but that's not what we needed. The domain of f of g of x is going to be the set of all x values such that x is somewhere between 1/2, greater than or equal to -1/2, all the way up to 1/2, but x also cannot equal 0. Okay guys, so we have reached the final example, example 5. We're going to find the first 3 iterates. I know we haven't talked about it, and I know I skipped it in the beginning when we talked about this lesson, but it's going to make sense, I promise. So find the first 3 iterates, x of 1, x of 2, x of 3, of the function f of x is equal to 2x minus 3 for the initial value of x sub 0, which is equal to 1. So what we're basically doing, an iterate is found by substituting the value in. So watch this. So I start off the way I like to start off, which is the blank version of my function. F of blank is equal to 2 times blank minus 3. And so we know that the initial value that we're talking about, x sub 0, is equal to 1. So that's the first value we plug in. Once we plug in the 1, the value we get here is going to be x sub 1. Okay, so watch this. So f of 1 is equal to 2 times 1, which is 2, minus 3, which is -1. So x sub 1, let me put it over here to look neater, x sub 1 is equal to 1. How do we get the next one? I think you kind of know. We're going to start off with our blank function again, just like this. And what we're going to do is plug in the value for x sub 1. What was that? It was -1. And I think I lost my negative there. That looks bad. Let's try one more time. So it was x sub 1 is equal to -1. So I'm going to put a -1 in here. 2 times -1 minus 3 is actually now -5. And that is x sub 2. And if you can allow me to let the drumming continue, I'm going to finish talking to you guys. So x sub 2 is equal to -5. To find x sub 3, we're going to go f of blank is equal to 2 times blank minus 3. We're going to put that -5 in there, guys, and we have finished our final example as soon as I tell you what x sub 3 is. X sub 3 is going to be negative 10 minus 3, which is negative 13. So x sub 3 is negative 13. So we found the values, and I can let my son practice in peace without me bothering him. Guys, I hope you're doing well. I hope this made sense. Take time to review the video, and don't forget to ask me or anybody who can help you questions. Take it easy. Bye-bye.